This is Algebra 1, Term 5, Lesson 3, Square Roots. We'll start with the Desmos classroom activity and we'll look at the history of square roots and what they're used for. Then we'll do a very quick task in graspable math, simplifying square roots, and we'll finish up in our slides by solving problems that involve simplifying square root. In our Desmos classroom activity, we will discover the origins of square roots. We'll examine models of square roots and perfect squares. We'll find decimal approximations. So we're just kind of going down into the purpose of these symbols. Why do we need them? What are they used for? Here they're told that this is a perfect square with integer side lengths. Here they can create squares of different sizes by dragging the red dot, and then they will record in the table the total area of the blue square. On this screen they're asked the side length for a square if its area is 100 square units. Here we're introduced to the square root symbol. They've used these before because we have solved quadratics, but now we're looking at why do we need these? What's the point? What's the purpose? Here we have a square that has irrational side lengths. Use a decimal to approximate the length of the purple side. And on this side, they'll be able to get it way more accurate by dragging until they get this area to be as close to 40 square units as possible. And then they will use that to approximate the square root of 40. They will choose an integer less than square root of 40, but very close to square root of 40, greater than square root of 40, but also close. And then using those two numbers, they can then approximate the decimal number for the square root of 40. How do we know the square root of 40 is between 6 and 7? And this diagram should give them some indication as to why. And then on this one, they're going to use these squares in this graph to approximate the decimal value for the square root of 5, square root of 32, and the square root of 70. In this screen, they will match up a decimal approximation with a radical and with a model. This is a self-checking activity. There are 15 cards in the activity, and when they get them all paired up, there's 5 groups of 3 cards. It will say that at the top of the screen. Okay, here is where we're going to get into some technicalities. We don't want students always giving a decimal approximation for square root expressions. And unfortunately, when we get them in high school, that is usually the first thing they're going to do is type it in a calculator, get a decimal, and write down a decimal. But we do want to encourage students to not give decimal approximations unless they are specifically requested in the directions to a task. So I have to kind of break them of that habit, and this is where it begins with this particular screen. They are given a side of a square. Which of these expressions would contain a square root symbol of the 3 that are given here? They'll use that same idea to express the side of this square with a square root symbol. This is telling them the origins of the square root actually came about. It was the Babylonians. I did not include that here, but it was well over 3,800 years ago that they first used the concept of square roots. The symbol for square root came much, much later. I did not give them the research article about this, but if you would like to, I have given a link to the research articles that I'm pulling from in your teacher moves. And if you want to go beyond what's in this activity and do a deeper dive into the history, that would be fun. That would be a good activity, something a little different. Your kids might enjoy it. All right, the next thing they did centuries later is decide on a definition of a square root. And so the definition says a square root of a number x is a number y such that y squared is equal to x. Now, according to that definition, which of these answers is best for the square root of 36? Then we go into the principal square root, which is what we use all the time in mathematics classes, but we don't often talk about that other answer that we're dropping. So At this point, we can start talking about that other answer. We have been getting two answers to our quadratic equations, the plus and the minus, so they kind of already have an intuitive feel for these things. But now they're understanding why that is and why those things are happening. Now we're getting into some vocabulary and algebraic methods. Now, we don't really get too deep into these other types of roots, but we do have to do rational exponents. And so this is kind of leading them into that. We will get to that in a later lesson, but I'm just showing them the vocabulary related to these symbols. The square root has an index, but you can't see it. The cube root has an index of 3. The fourth root has an index of 4. The fifth root has an index of 5, and so forth. And they are basically using what they're seeing here to find the index and the radicand for the expression sixth root of 17. This tells them up here that the first time this symbol showed up in print was in 1525. So mathematicians worked with square roots long before 1525, but until they started doing algebraic methods, they didn't really need the symbol. And then when they started with the algebraic methods, they created the symbol to facilitate those methods. All right, and then now they're going to answer the question here. What do you think the index is for a square root? You can't see it, but what could it be? Our next activity is in graspable math, and there are a total of 10 different screens. The first is a canvas, and the rest are goal state. Now, when they do go into their canvas, they will see a video, and they will follow along and simplify these two expressions. Once they've done that, they will submit and go on to the goal state questions. Now, for the goal state questions, just like in the video, they're going to need to press the keypad. Then they'll press the number, and then they will change the number into a product of two numbers, and they want to have one of those numbers to be a perfect square and the other number to be not a perfect square. We're going to change this into 4 times 10. And then you'll take the 4 and drag it to the left, and it will split it into square root of 4 times the square root of 10, and then you'll tap on the square root of 4, and then it turns green. So you have simplified the square root expression. They will need to know how to simplify square root expressions to complete their slides, so they should do this first. So in their slides, they'll be doing first 2 skill tasks, which is looking at a problem that has already been solved and explaining step by step the process that was used. The next screen they'll notice is using the quadratic formula. So they're asked what happened for each step. So hopefully the first step they'll know and recognize the quadratic formula, and then they can talk about how it is being simplified all the way down to the bottom. Okay, the last part of this activity will involve solving quadratic equations in a context. So how can you use this equation to find how long it will take for the object to reach the ground? So they're basically going back to a problem they worked in the past with a graph, and this time we're applying an equation. Here's another one. Another object is launched upward, and this is a different type of equation. Find the number of seconds it will take by solving an equation with the quadratic formula. And then finally, this is the same equation, but a different question. It says, I want to know 2 different times when the object will be 64 feet above the ground. Use equations to solve and find these answers. Insert images of your work. I'm not telling them how to do it, but I am telling them I don't want just a graph. I want to know how you can find these answers with equations. And that concludes our square roots lesson. Y'all have a great day.